calculations. All right, we talked about Boyle's law previously. Another scientist we're going to talk about now is Charles' law. So this is an introduction. We'll do some calculations in another video. Okay. Now Charles' law, folks. Okay. Once again, I like to use the combined gas law first and work backwards. Okay. So Charles' law, he did experiments, right? But he did them at constant pressure. Okay. So let's make a note of that. The pressure, okay, you see, fixed, constant pressure. It's important we know that, all right? So pressure was fixed or constant, okay, no problem. So, if we have P1, V1 over T1 equals to P2, V2 over T2. Remember, guys, this is the combined gas law. It's on table T, your reference table. P, V, and T, pressure, volume, and temperature. Okay, that's listed for you. The ones mean initial or starting or old. The twos mean final, ending, or new. Okay, so we discussed that before, no problem, right? So, we have pressure constant, right? So when pressure's constant, we agreed in class, right? We can turn these guys into ones, right? There. Now if you put ones here and ones there in place of the pressures, guess what happens? 1 times anything is that same thing, right? Alrighty, bam. Bam, okay? So now, what do we have? We have V1 over T1 equal to V2 over T2, okay? Now, what's gonna happen is, they'll have a relationship too, right? But we're not gonna guess what the relationship is. We're gonna look at it carefully. Now here's the analogy. Let's say, right, we have a balloon, okay? Bam. At some point in our lives, we've all, had experiences with balloons, right? And I'm gonna use some made-up numbers, guys, okay? All right. So let's say this is 200 Kelvin right here. Same balloon, let's put some dots in here to represent gas particles. I'll put 6 gas particles in there, no problem. We have 200 Kelvin of temperature. Let's say the balloon is at 400 mL in terms of volume. Okay, once again, I'm making up numbers. All right, guys? All right, don't write me. So, we're going to apply more heat. We're going to raise the temperature. We're going to double it to 400 Kelvin. Now, what do you expect to happen to the size of the balloon? Now, we're going to use common sense. From kinetic molecular theory, from our real-world experiences, right? We expect from hot air balloon experiences, right? That we saw or so on. We expect that the balloon will expand, right? So no problem. And it just so happens, it does expand. 1, 2, 3, 4, 5, 6, yes? Okay? Now, what is going to expand to? It actually expands to 800. Now, how do I know that? Because Charles' law, right? Between temperature and volume, they have a direct and proportional relationship. So you're gonna write that down. It has a direct and proportional, okay, relationship. It's very important that you know that. So what does direct and proportional mean? Direct simply means that whatever one variable does, the other variable follows in the same direction, same way, okay? Proportional means that there's some number that they're both related with, okay? So for example, if the temperature here, the T, is being doubled, okay, this V right here is also gonna get doubled, okay? So we go from 200 to 400. Okay, here we're going from 400 to 800, so they both got doubled, okay? If I decrease the temperature, okay, the volume will get decreased in that same proportion, right? So that's the key of direct and proportional for Charles' law. Okay, now another thing you should know, V over T for Charles' law, right? Very important. Will give you some constant number. So what do I mean? let's say you're doing experiments, right? Let's say in college or in high school, no problem. Okay, when you take your data, say a number of much more samples than this, okay, when you divide V over T, you will get roughly the same number. So for example, you got 400 right here, you divide it by 200, what do you get? Okay, 2, right? Okay, you got 800 divided by 400, what do you get? 2, and so on, right? So you can actually predict roughly what number should be here, okay, if you're following this proportionality. All right, you got 200, you got 400. You're thinking 800 should be for the temperature, right? You got 4, 8. You're expecting 1600 should be there for the volume. Okay. All right. So, as we're wrapping up the introduction of Charles' law, okay, we got V1 over T1 equals to V2 over T2. I tell my students, right, don't leave it like this and use it like this, right? Always when we're gonna do Charles' law, we are going to crisscross or cross multiply the temperatures to make our life simple. So what do I mean? When we crisscross or cross multiply the temperatures, we will get V1 T2 equals to V2 T1. Okay, so after we cross multiply temperatures, so we will use this later on when we're doing our calculations this way right here, okay? Now guys, when you're doing Charles' law calculations and temperatures involved, you must use Kelvin temperature, okay? So write that down someplace, guys, okay? You must use Kelvin temperature, TMP for short, bam, exclamation points, all right? You gotta use Kelvin temperature. Now, on your reference table, they show you how to convert degree C to Kelvin, yes? So no, don't have to worry about that. Just look at the back, bam, whatever degree C you have, you add 273, bam, you're done, right? But you've got to use Kelvin, because sometimes students forget, okay? Sometimes they give you the problem with Kelvin, no problem, but sometimes they give you the problem with degree C, you must convert it to Kelvin temperature. All right, folks, let's wrap it up. One last thing. Common sense question. If temperature and volume, right, have a direct and proportional relationship, right? What do you expect the Charles' law graph to look like? It's a thinking question. Okay, you have the Charles' law graph, all right? You got temperature, you got volume. The graph will look like what, folks? Will it look like a curve, single line, what? Okay? It just so happens, right? The graph looks like this, a nice straight diagonal line like this. And that makes sense, okay? Because this is my temperature, my right is my temperature, and my left is my volume, okay? As temperature goes up, volume also does the same thing proportionally, guys, okay? As temperature goes down, volume also goes down proportionally, okay? So it's like this, all right? Bam, bam, they're following each other. Temperature increases temperature, the volume goes up. You decrease temperature, volume goes down, okay? So it makes sense that it's a nice straight diagonal line like that. Now you have to know the graphs for the different laws, people. Don't guess, just don't memorize it for memorizing its sake. Analyze the situation. My temperature's increasing, my volume's gonna increase. It's direct and proportional. It makes sense, it looks like this, okay? As opposed to looking like a Boyle's law graph, right? Where one's going up and one's going down, but that's inverse, okay? So know your terminologies. Know what direct means, know what inverse means, and so on. Know your units, okay? And you'll be okay. So next video, we'll do some calculations with Charles' law. All right, guys, as always, hard work plus sacrifice equals success. Take care.